Hello again, everyone. Mr. Cruze here with another probability and statistics review for you. This time, we're going to be looking at z-score stuff. How to use z-scores, how to find a z-score, how to find probabilities from a z-table, as well as how to work backwards. So we're going to do all that in this video. Hopefully it'll be a good time, alright? So we'll start with the setup. The distribution of weights of 9-ounce bags of a particular brand of potato chips is approximately normal. That's very important. It must be approximately normal, otherwise we can't do this. With mean of 9.12 ounces and a standard deviation of 0.05 ounces. So I know you might be thinking, first off, they're 9-ounce bags, Mr. Cruze. How is the mean 9.12? Well, they're not exactly 9 ounces, okay? That's just what we round them to, but in reality, they do vary between them. So that's why the mean is 9.12 and not exactly 9. That's not relevant for the problem, okay? Anyway, we're going to answer the following questions. So remember, there's going to be two types of these questions. We have type A problems, and we have type B, okay? Type A problems basically ask you to do the following. They ask you to find a probability, okay? So you're trying to find a probability. By the way, that can be area. That could also be proportion. That could be percent. Any of those are the same sort of question. So the first step is, once you're trying to find the probability, you're going to have to find a z-score first. Find a z-score, okay? So to do that, we use the following formula. Z equals x minus mu over sigma. That's the important formula that we'll be using this time around, okay? So we need three things to find a z-score. We need an x value, which is called your boundary value. So they want less than 9 ounces. Another way they could ask this is probability x is less than 9, right? So 9 is our x value. Minus mu, which happens to be 9.12. And we're going to divide by sigma, which is 0.05. Okay? So 9 minus 9.12 divided by 0.05. All right? So that's going to be our z-score. So anyway, a quick type in that calculator, 9 minus 9.12, and then divide that by 0.05. You get a z-score of negative 2.4. So really what this question is asking is, not only is probability x less than 9, we're really trying to find what's the probability that I get a z-score less than negative 2.4. Okay? That's really what we're trying to find. Once you find a z-score, you're going to look up the z-score on the table. Okay? That big yellow table that I gave you with all those values. Alright? I happen to have one here. Whoop. So, we're going to look up negative 2.4, and technically that's negative 2.40, so we're going to look up negative 2.4, and then we go over to the 0 column, and that'll be 0.0082. 0.0082. So my probability is 0.0082. Now, there's just one little catch, okay? We might have to adjust the probability, okay? Or the percent, however you want to look at it. When I say adjust, it all depends on the type of question. If it's less than, you just look it straight up on the table. And the reason for that is because the table gives you, you notice how this area is shaded over here, it gives you the area to the left of the z-score. It gives you the less than, okay? If it's greater than, you'll have to subtract from 1, which you'll see in the next example. And then if it's between, you look up both z-scores and then subtract their probabilities, okay? Since this one is strictly less than, boom, that's our probability, okay? And by the way, it might help you to sketch the picture so that you can actually see what is happening, okay? If my mean is 9.12 and I was looking for 9, 9 is obviously to the left, and I want less than, so that's why it's shaded. My sketch isn't perfect, but you could reasonably see that that percent makes sense. It's less than 50%, it's very tiny, right? So my answer makes sense. All right, B, find the probability that a 9-ounce bag weighs at least 9.06 ounces. That'll be important. 9.06, at least 9.06. Still a type A, because we're still finding the probability. So, again, the first step is find a z-score. So we're going to do x minus mu divided by sigma. And that will give us a z-score of negative 1.2. Okay? So, now here's the trick. We have to figure out what does at least mean. If I say I ate at least 8 cupcakes, does that mean I ate 8 or fewer cupcakes, or does that mean I ate 8 or more cupcakes? Well, if I ate at least 8 cupcakes, 8 would work, 9 would work, 10 would work. It's bigger, okay? Essentially what they're asking for is greater than, and really it's greater than or equal to, but that doesn't matter for these problems. Okay, so anyway, it's a greater than problem, so I'm looking for greater than negative 1.2 on my z-score. Okay, so the first thing we're going to do is we're going to go to the table. Negative 1.2, we're going to scroll down just a wee bit. Negative 1.20 is right here. That's 0.1151. Okay, but that's not our answer. Okay, and again, if we were to sketch this, we would see, again, 9.12, 9.06 is a little bit closer this time, but I want at least, so that would be shaded to the right. Well, clearly that's more than half the graph, right? So 11.51% wouldn't make sense. So this is where you have to subtract from 1. If it's greater than, subtract that probability from the table from 1. If you do, you get 0.8849 as your probability. That seems more reasonable, 88.49%. Okay. Now, find the probability that a 9-ounce bag weighs between 9.09 ounces and 9.16. So notice between this time, okay? So again, drawing myself a quick sketch, 9.12 in the middle, 9.09 is somewhere here, and 9.16 is somewhere over here. Just a sketch, I don't care. But I'm between these two values, okay? So again, maybe a little harder to eyeball this one, but you still kind of get the idea of what we're trying to find, all right? This time, since there's two x values, we're going to have to find two z-scores. That's okay, the formula doesn't change. So x minus mu divided by sigma. And the same thing over here. Z-score equals x minus mu divided by sigma. All right? So obviously we're going to get two z-scores here, and it turns out one's going to be negative, one's going to be positive. The first one is negative 0.06, or I'm sorry, negative 0.6, my fault. And the second one should be 0.8. Okay, so we're between two z-scores, negative 0.60 and 0.80. If it helps you write that second place, go for it. Okay, so again, with between, the trick is you're going to look up both of these z-scores on our table, and then we will subtract them. Okay, do not subtract the z-scores. Very important, do not subtract the z-scores. You must subtract the probabilities instead. So we're going to scroll down a little bit. Negative 0.60 is 0.2743. 0.2743. And if I go to 0.80, that's 0.7881. Okay, essentially here's what that means, and I want to give you this picture so that you can kind of see it. If I look up 0.80 on the table, that's everything to the left of that z-score. Okay, that's 78.81%. That seems pretty reasonable, but unfortunately that's not what I want. I don't want this bottom tail section. I want to get rid of it. I just want this, right? So the trick is to subtract out what's to the left of that other z-score, okay, which is the 0.2743. So anyway, that's why we subtract on the between. So we're going to do 0.7881 minus 2743. Be sure to always do bigger minus smaller, and if you do, you get 0.5138 or 51.38%. Either answer is totally fine. Okay, those are all the type A questions we could ask you. Less than, greater than, and between. Okay, now comes the type B questions. So type B, this time you are given a probability or a percent. Okay, usually I suppose it's a percent. I should probably write percent. But anyway, you're given a percent this time. First step again is still find the z-score. Okay, you still must find a z-score. This time, and I'll keep saying this, you must look for the z-score that is or the percent that is less than the z-score you're trying to find. Okay, and we'll say that a lot. Once you find a z-score, use the formula to turn it into an x. Okay, to convert it to an x. I think the type B questions are the harder of the questions we can ask you, but really, if you take your time with them, they're not as hard as they appear. Find the weights of 9-ounce bags that separates the middle 70%. Okay, the middle 70%. Really helpful on these to sketch yourself a picture. Okay, the mean was at 9.12. the middle 70%. So that means there are two z-scores, one of them negative, one of them positive, that separates the middle 70%. So this yellow shaded region is 70%. Okay? By the way, because it's in the middle, these two z-scores are going to be the same value, just one of them negative, one of them positive. Okay? So we don't quite know the actual value yet, but we will find it. Okay? So, how do we do that? Well, there's 70% in the middle. Okay, that's great. We can figure that out. But unfortunately, if you just go to the table and look up 70%, you're not going to get the right answer. You need to figure out what percent is below your z-score. What percent's actually right here? If I can look that up on the table, then boom, I got the z-score. Okay? Well, it turns out if 70%'s in the middle, there's 30% in both of these tails, right? And since the normal distribution is symmetric, 30% divided by 2 would have to be 15%. Okay? Together they all have to add up to 100%. All right? So, if I can find the z-score that cuts off 15%, we win. Now, this time, you're not looking on the side. Those are z-scores. We have a percent. All right? So we're actually going to be here in the middle, the sea of numbers, as I call it. And we're going to look for the closest thing to 0.1500. And you notice there's two choices here. There's 0.1492 and 0.1515. Well, which one's closer to 1500? Would that be 1492 or 1515? 1492 is the closer of the two. So I look to the left. I see it's negative 1.0. And then I look up, and it's 4. So that would be negative 1.04. So my z-score is negative 1.04. And by the way, that's the negative version, and since it's the middle, these z-scores have to be the same. So those are the two z-scores, and now I can turn them into x values simply by doing this, using the formula and plugging in what I know. So negative 1.04 equals x, which I don't know, minus the mean divided by sigma. All right? Little algebra here, you just take negative 1.04 times 0.05, which if you do, you get negative 0.052, and that equals x minus 9.12. And now you add 9.12 to that, and you get a lower value of 9.068 ounces. Okay, that's the lower end. Now to get the upper end, I just use the other z-score, positive 1.04. Equals the same exact expression on the other side. Once again, you take 1.04 this time times 0.05. You get 0.052 equals x minus 9.12. And now you're going to add 9.12. So it turns out the upper end, 9.172. Those are your two values. And as I've said, the hardest part about this is figuring out what percent lies below that z-score. Alright, let's do this one. Find the weight greater than the mean of 9-ounce bags that has 20% of bag weights between it and the mean. So find the weight greater than the mean. So we're going to be above the mean. Alright. So it's going to be some value above the mean. We don't know what it is. That has 20% between it. I guess I'll use my yellow. Has 20% between it and the mean. Alright. Again, the magic question of the day is, forget that 20%. What matters more is what's the percent that lies entirely below that z value. Okay? And the answer, it turns out to be, is actually 70%, because there's 50% to the left of the mean, right? For a total of 70% left of z. So there's 70% total here. So we're going to go to our table. We look up the closest thing. Obviously, this is a positive z-score, so we're going to be over here. Closest thing to 0.7000. We have two choices, 0.6985 and 0.7019. 6985 is actually closer, so 0.52 is our z-score. So then what you do is you take 0.52 and you just plug it into your formula, x minus 9.12 divided by 0.05. And once again, you do the algebra. Multiply by 0.05, which should be 0.026. That equals x minus 9.12. And now we add, X ends up being 9.146. All right. Good luck.